Hello, everybody. Good morning, good evening, good afternoon, and thank you for joining Graph Academy Live in April with Martin. Hi, Martin. How's it going?
Hi, Alex. How are you?
I'm good. I'm good. I'm looking forward to this one, even though I just realized my lighting is a little bit off today. But I'm not unwell. I can tell you that.
That reminds me.
Yeah. Yours look now. Mine look even worse, but that's all right. I'll go away in a second anyway. So no, today we are looking at the Neo4j and LLM fundamentals course, and as last time we kind of start with outlining the training a little bit, give you a glimpse of what to expect with the actual Neo4j Graph Academy course you can do for full, and then we just dive in and show you how it starts, and give you the option obviously to ask your questions and give your comments. So that would be great if you maybe already if you've done it before and then maybe you struggled with something, maybe you want to just give feedback, positive or negative, everything's welcome. Or if you just continue as of today for the first time with Martin, then it's also nice to hear your impression and to see if if something you want to know a little bit more about. This is your chance to actually ask questions and to reach out to us during the session. So should be fun, should be interactive. So I'm encouraging that, and I'd like to have you write anything you'd like to talk about in chat. If you want to enroll to the course right now, then I put the link in chat. It's also in the video description. But I think, Martin, you probably go there as well in a second and showcase that. As ever, I'll be here. I'll be probably more off camera as usual, but I'll come back for breaks and for questions. And I wish you good time. Have fun.
Thanks, Alex. Thanks, buddy. Right, I'm just going to move my screens about, so just ignore me while I look from side to side and kind of make sure everything's in the right place. It's great to see you all. So what we're going to do today is Graph Academy Live. We are going to go through our Graph Academy course, Neo4j and LLM fundamentals. So as Alex said, the link is in the course, in the chat. I'm just going to share my screen. Just give me 1 second while I get that ready. There we go. So yeah, let's just quickly share this screen. Great.
Here we go.
Brilliant. Great. So yeah, hopefully you can see Neo4j Graph Academy. You can get to Neo4j Graph Academy by going to graphacademy.neo4j.com. I'm just going to make. Well, you could have done had I not just closed the window. That was a genius move on. I mean, what a great start. So
reset, rewind.
Let's try
again.
that again.
While you're at it, Martin, do you mind clicking on the little hide button at the bottom of your screen?
Oh, of course. Let's get rid of that as well.
Thank you.
And let's just make that a little bit bigger, which was what I was trying to do, and I managed to close the window. Okay, so yeah, Graph Academy. So Graph Academy is Neo4j's online training platform. You can find free, as it says, free self-paced hands-on training. That you'll find courses and certifications as well. So we are going to go through a course today called Neo4j and LLM Fundamentals. So if you find yourself on Graph Academy, you can go to this course. You'll need to log in if you haven't already. There's a little sign-in button at the top where you can log in. You can log in with Google, any other kind of social media accounts, or you can make your own. But yeah, so we're going to go for Neo4j and LLM fundamentals course. So just to kind of talk about the course a little bit before we get straight in there. So this is a introductory course to how to integrate Neo4j with generative AI models, predominantly using Python and Langchain. So we are going to look at why graph databases are a good option for grounding LLMs. We're also going to use Langchain and Python, hopefully, as we kind of get into the course, to integrate an OpenAI, in this case ChatGPT, large language model with Neo4j using Python and Langchain. The course will use we're going to use OpenAI. However, Langchain will work with the kind of LLM of your choice, and almost everything we talk about is cross-transferable between different LLMs. So before we start, we should talk about prereqs. So things you should know: have a basic understanding of graph databases and Neo4j, and have a working knowledge of Python, kind of able to read programs. Right, let's kind of get straight into this. So this is about a sort of 2-hour-ish course, depending on how deep you kind of want to get into the practical activities. You could take it a lot further than that. So we probably won't get through the whole of this course in an hour, but we'll certainly kind of like get ourselves into a good position to kind of continue. So first thing we're going to do is we're going to enroll. So we enroll on the course, and we go straight in. So the course is made up into a collection of modules. So the first one we're going to start off is we're going to learn a little bit of theory around Neo4j and generative AI. So we're going to start to explain some of those terms like large language model, knowledge graph, hallucination, RAG or retrieval augmented generation, and look at some of the kind of techniques that we can use to gain control of our large language models. So I'm ready. Let's go. So let's just talk a little bit about Neo4j and GenAI. So I'm going to assume that you all know what Neo4j is, but summary being Neo4j is a graph database and analytics schemes, analytics systems, incredibly useful for understanding highly connected data. So what are knowledge graphs? So knowledge graphs are a particular implementation of a graph database, as the kind of text says. And really what sets a knowledge graph apart is it's the integration of information and data from lots of different sources, kind of like structured in a way that it kind of represents the entities, their attributes or the properties, but also understanding how that data connects with one another. So, if we were going to look at an abstract form of a knowledge graph, it's that idea of having sources, breaking down source data into more manageable pieces, and then using things like topics to join those sources of data together. It's a very abstract form. Now, you may not be familiar with the term knowledge graph, but you have almost certainly use one. Lots of search engines typically use a knowledge graph type structure to provide information about kind of people, places, and things. So if I kind of like imagine a knowledge graph that describes Neo4j and where Neo4j may sit. Neo4j is a company. It was founded in Malmo, which is a location. Neo4j also has a location in London. London happens to be the capital of the United Kingdom. Neo4j has a website, neo4j.com, where you may publish information about blog posts. May also have documentation, and those blog posts may refer to technologies. But again, a knowledge graph encompasses lots and lots of different entities and allows you to interact with that data in a way to understand how those seemingly maybe at the start of data gathering, how those entities are connected together. Anyway, this integration of kind of like really diverse sources gives knowledge graphs a really good holistic view. The great thing about knowledge graphs is we can readily adapt them and evolve them. And as we'll talk about later, knowledge graphs are becoming a go-to need in order to ground LLMs or provide LLMs with context. Yeah, and we'll kind of go through those things. So we'll talk about a few more terms, make sure everybody's on the same page. So large language models, or LLMs, we may also refer to them as ChatGPT. It's become a word that is ubiquitous amongst throughout society almost now, regardless of whether you work in technology. ChatGPT sitting on top of LLM's GPT-4 large language model, LLM. LLMs are essentially machine learning models trained on huge amounts of text data, and their goal is to generate human-like text. And by looking at their training data, by looking at a question or a prompt that's been given to them, they can come up with a probabilistic reply, right? And I'm using kind of my words sort of sensitively here. LLMs don't think, they don't kind of question, right? It is a model which, if you ultimately, if you asked an LLM to continue the sequence ABC, it would respond with DEF. That's their job, right? They look at a prompt and they provide a response which is a continuation of that of the instruction that it receives. So let's kind of like look at an idea. So to get an LLM to perform a task, you provide a prompt or a question. But it's called a prompt, and it's a piece of text that sort of specifies what you want, and that's that piece of text that the LLM is going to create a continuation of. It's going to create a response to. So in this case, I've got a user. What is an LLM? But it's also giving further instructions. What is an LLM? Give the response using simple language, avoiding jargon. And an LLM will respond, or could respond with, an LLM or large language model is a kind of computer program designed to work with human language. That is what they are. So when we are going to spend a lot of time talking about prompts and about prompt engineering and about using prompts to LLMs to get the sort of responses that we want and need. So precision in the task description, so the prompt, if we combine that with real world examples or context, it ensures that the response that we get back is of greater quality. An example of a very simple question could be, what is the capital of Japan? So Tokyo. Or it could be much more descriptive. Tell me about the capital of Japan. Produce a brief list of talking points about its culture. The content should be targeted at tourists. Your readers may have a language that may have English as a second language. You kind of get the idea. Much more descriptive questions will result in a response which is more concise, potentially, if you've asked it to be more concise, but more relevant to the prompt that's been given to it. I just need to take a sip of water. So, like, LLMs provide huge amounts of potential, but I'm going to offer a word of caution. At their core, LLMs are trained, as we talked about, to predict the following words in a sequence. Now those words are based on patterns and relationships from text in its training data. Now, that training data may have come from publicly available text. Almost always has come from publicly available text, and could be of, I've used the words here in this course, of questionable quality. And also training happens at a point in time, and it may not reflect the current state of the world. And we know that the world changes very, very quickly. And it would also not include any private information. And often LLMs are tuned to be as helpful as possible, right? Even if that means generating something that's misleading or baseless, because what they're doing is they're trained to create a response. I mean, I've used a sort of slightly silly example here, which is, if you ask the moon, an LLM to describe the moon, it may respond with, the moon is made of cheese, because it's a common saying, and it will probably exist within publicly available text, right? But obviously it's not true, right? But the LLM doesn't know fact. All it knows is publicly available training data. That's something that's been said. So we've started to talk about things like hallucinations, right? Which is essentially making things up. And we can help fix hallucinations by providing contextual data. So providing information within the prompt that allows the LLM to be more accurate. So the LLM gets information from its training data, but also from the prompt that you give it. And And going back to knowledge graphs, a knowledge graph is a great mechanism providing that additional data to an LLM. It allows us to gather contextual data from lots and lots of different sources very quickly, and we can use that to ground an LLM, so to provide it with information that allows it to create a better response. So hallucinations. GraphAcademy wouldn't be GraphAcademy without a couple of questions at the end of it. So let's try and do these. What is the name of given to a confident but incorrectly answer provided by an LLM? Well, it's not a daydream, it's a hallucination. Why might an LLM produce outputs that manifest as generating untrue facts or nonsensical explanations? Well, LLMs rely on patterns and sometimes overfit based on the data that they've been trained on. Hopefully I get these right, and I have. There will be one at some point that I get wrong, I'm sure, just because I'm not thinking. So we're going to spend a lot of time talking about things like avoiding hallucinations. So I'm just going to introduce a few techniques for doing that, and then we'll kind of look at these in greater detail. So let's look at some ways of avoiding kind of common hallucination problems. So one of them is temperature. Lots of large language models, including OpenAI's GPT-4, have a temperature, and that corresponds to the amount of randomness, for want of a better word, that the underlying model should use. The higher the temperature value, the more random the generated result will become, and it's more likely to have false statements in there. However, if you want an LLM to produce a more diverse or creative output, actually a higher temperature might not be such a bad thing. Whereas a lower temperature is the response is more likely to be grounded in fact. Yeah. And quite often a quick fix, if you're you're working with an LLM, is just to reduce that temperature. Missing information, we talked about, LLMs are trained on data, and it's that data is trained at a point in time. It's not a real-time thing. So, if an LLM's last update was, a couple of years in the past, it would be unaware of information. Unaware of information that's kind of happened since then. But we can provide information within our prompt that allows an LLM to be more successful. The other one that's also worth thinking about is when LLMs are trained, the training and the models are incredibly complex, and LLMs are often referred to as black boxes because it can be almost impossible to know how an LLM determines the response that it gave you. And interestingly, you would struggle to ask it that question. It simply wouldn't know. But there's things that we can do to improve LLM accuracy. So prompt engineering, as we talked about. So we saw some examples of providing positive instructions within a prompt. So, in this example, return the response as JSON. And providing additional instructions and context in the question is known as zero-shot learning. We can also provide in-context learning. So this is where we can provide relevant examples. So, if we want the LLM to respond in certain ways, we can include examples of how it should respond with certain for certain types of prompts. And again, this is known as few-shot learning. There's also fine tuning. You can take an LLM and fine tune it for your own particular need. This is certainly the most complex option available to you, and it's probably going to be pretty expensive as well. We're going to talk a lot about grounding. So grounding is where we give the large language model referenced external up-to-date data. So kind of an example that we're just kind of expanding on here is the idea of a news chatbot. Now, a news chatbot, powered by an LLM, would create useful and sort of human-like responses. However, it wouldn't know the latest news. So, that idea of, what's the latest news on the Olympics? Today a world record has been broken. LLM wouldn't know that, but by using real-time data, you can provide grounding to an LLM. So additional information that the LLM can use in conjunction with its training data to provide a more useful response. Great. I'm going to sort of stop at this point and just sort of say, have we got any questions? Because we've spoken a lot. This might be a good time to have a quick break.
Is a good point for a break. I can only repeat what I said in the beginning to ask questions. I see one that is very specific. So Darren, don't take it wrongly, but maybe we'll table that a little bit either for end of the session or maybe for indeed the community forums or the Discord server, because I think it goes a little bit too far for too specifically for this session. But generally these venues stay open all times, and maybe take them there. But if you have a question about today's episode and what you like to know more about the specific course today, I think it makes I would like it to invite you to ask questions, but if you some time, maybe we can go there at the end. The other one is a comment, maybe more of a comment than anything else, from Rob. He says, I dig how prompt engineering is akin to dealing with other people. The more specific you are, the chances are higher you will get a better response.
Yeah. The more information that you give, generally the higher the quality of the output, I think, is the kind of answer there. Okay.
And then Jonathan asked a question: is the answer of real-time data used for the LLM as input data?
Yes. Yeah, essentially. Yeah. And this particular model here that we're looking at, that idea of using real-time data and passing that real-time data with the prompt to the LLM, so the LLM can use the prompt that's got real-time data as well as the question and its training data to provide a human-like response.
And then one more question from William. He says, could you explain zero shot again?
I will do my very best. Oh, okay, yeah. So and I must admit, I kind of whizzed over this. So, this is the idea of, a prompt can be as simple as the question you want to ask. Yeah. So, I think the example used here is, what is this blog post about? Or it could be, something more specific, like provide a concise 3-sentence summary and 3 tags for this blog post. Yeah. So within the prompt itself, we're being much more specific. Yeah. And we can also add instructions. And again, this is, return the response as JSON, but it could be format the response in a particular way, assume that you are undertaking a certain role, maybe as an expert or actually maybe as a teacher. Yeah. And by providing those kind of like detailed instructions within the prompt, you can get a more appropriate, I'm trying to use the right words because I don't want to use a more useful response from the LLM.
Okay,
cool. Should we move on?
There's one more maybe on the diagram here that you just showed.
Oh, sorry, I've just gone through this one here.
Yeah, you wrote API in the diagram and mentioned that helps in grounding, means that we can integrate LLM with an API or via an API.
Oh, so what I was just sort of trying to express with this diagram here is the training data that the LLM uses will be from a point in time, i.e., not real time. We could use a news API to gain some real time data that we could then use within the prompt that we then send to the LLM.
Yeah, cool.
All right, cool. Okay, let's move on. We've got more questions again. Does a higher temperature setting impact the outputs of an LLM? How does it? A higher temperature sensing increases randomness and creativity of the output using external data. What approach allows a language model to reference external up-to-date sources such as APIs? Grounding. Excellent. So I'm pleased that I wrote this course and I'm getting the questions right. But like I say, there will be at least one I get wrong, right? So let's just go a little bit more into grounding, and again, let's repeat The reasons be it, data cutoff dates, and is a big problem. If you run it, if you're asking any type of real time question, it can be really challenging. So retrieval augmented generation, or RAG, is an approach for grounding. Right now, RAG combines the strengths of a large language model, with external retrieval and kind of search mechanisms, and it's this allows us to take advantage of that LLM in terms of creating great human-like responses and finding relevant information. But we can also feed it with more up to date sources. So we're going to talk quite a lot about RAG. So let's go over some of the kind of main benefits. What we're talking about here is gaining enhanced accuracy. By pulling information from external sources, we can pass very specific information about the question that's being asked to the LLM, so it can have increased transparency, because we know the data, or at least some of the data, that the LLM has provided its response on. It also means that actually we can use publicly available LLMs, but we only pass it the data. We only pass it secure data via the prompt. So we're not exposing any data that we don't want to. As we've talked about, providing data within real time, but also access to private and proprietary data as well, which an LLM would not have access to. There's the constant, bad data in, bad data out. When we prompt an LLM to respond based on the context provided, the answer will always be as good as the provided context, right? If your if your prompt suggests pineapple as a pizza topping, don't be surprised if it suggests that you order a Hawaiian pizza. The idea here being, if we can provide really good context to our LLM, we'll get much better response. So let's go back to that news agency chatbot. So we could use RAG to support that news agency chatbot by allowing it to access real-time news feeds, which we had, pulling recent headlines and news articles from a database, and then by providing this context to an LLM. And if we use a knowledge graph in between that, we can use that knowledge graph to find really good contextual data that's kind of based on the relationships that we can determine both within the articles that we know about, and also obviously any kind of new and recent stories as well. So we are going to, during this course, we're going to explore some methods for implementing RAG with Neo4j. So we're going to look at semantic search, zero and few shot learning and prompts. We're also going to look at text embeddings and vector indexing, and Cypher generation, to supplement our unstructured data with structured data from that knowledge graph as well. Okay, which is not a benefit of retrieval augmented generation. Enhanced increased transparency, instantaneous training on new data. That is not a benefit of RAG. Great. So we've kind of reached the point now where we've done a lot of theory. Let's do some stuff. And the first thing we're going to look at is we're going to look at vectors and semantic search. So if we're thinking about how we ground an LLM, finding good contextual data is one of our first problems, and semantic search is a way to help us do that, and we can use vector indexing within Neo4j to help us do that semantic search. So what do I mean by semantic search? So semantic search, this is about trying to understand somebody's intent, rather than focusing on individual keywords. So, if somebody searches for apple, in a traditional search, you might get results about the fruit. However, in a semantic search, what we're trying to do is look at the context of that. Are they searching about the fruit, the tech company, or something completely different? And then with semantic search, we can tailor our results based on the perceived intent. That's the idea behind semantic search, and that's why we can get better results. Semantic search tends to be driven by vectors and embeddings. So in NLP or machine learning, we quite often create a numerical representation of words and phrases, right? Where we would create a vector, so a series of numbers. Let's put it, a vector, a series of numbers, and we can use those numbers to represent particular semantic aspects of a word or phrase. So what I mean by that is, let's take our Apple example. So let's say that we created a vector, so a series of numbers for the word apple. You could create, sort of encode tangible numbers like sort of color, taste, shape, but also things like health, nutritional, wellness, and when we then use that as a search, we can apply a semantic or an intent meaning behind it, rather than just a very, very simple apple is the word apple. Actually, apple has a meaning, right? It means the tech company, or does it mean the fruit? Well, actually, if it means the fruit, does it mean there's a relationship to the color green or to the color red for health, nutrition, wellness? And if you're from the UK, a doctor a day keeps the apple away, as being a popular saying. But that idea of being able to understand the meaning of a word based on lots and lots and lots of different dimensions. So, when we create an embedding for a word in kind of machine learning, it's often known as an embedding. So an embedding is a vector, a series of numbers. And one of the most common ways of creating an embedding is to use a large language model. So, for example, the embeddings for the word apple are, this great big old list of numbers. And if you're really interested, you can have a look at what they are. I created these embeddings using OpenAI's text embedding Ada 2 embedding model, which has, which creates a vector of 1,536 dimensions. So it tries to create dimensions, 1,500 odd dimensions for a word or for a phrase. But also, it's important to note that the kind of vectors for a phrase would subtly change based on, its context as well. So, I've used the example here. The word bank would have a different vector in riverbank than in savings bank. And we can use these semantic search systems to try and discover user intent. So anyway, once you create this great big old list of numbers, you can then use the distance or the angle between vectors, between these lists of numbers, to gauge the semantic similarity. So, for example, apple and fruit will have a distance. Apple and technology will have another distance. Apple and phone would have another distance. But actually, it's much more likely that you would create embeddings for phrases rather than simple words. I've used words here because it's an introduction. But creating an embedding for an entire phrase, and then you could see the distance between that and a different phrase. All right, cool. So semantic search, I mean, again, a typical diagram works a little bit like this. A user submits a query. The system would create an embedding of that query and pass that embedding to a vector index. The vector index would return results, typically scored on their similarity. So, a number of results with a similarity score between 1 for being most similar and 0 being least similar, and then the user would get back those results. So, I've been talking a lot about words, but interestingly, vectors can represent entire documents, images, audio, just about any kind of data type. It's really just dependent on the model that you've used to create that embedding. Neo4j supports a vector index, has done since I was going to say 5.11, since the 5.11 release, and allows you to query nodes based on vector representations. So what we're going to do now is we're going to have a quick look at a vector index. In fact, I'm going to skip straight over the test and go straight to that. So if you've done Graph Academy courses before, I'm sure you have come across our movie recommendations data set. So this is a data set of movies, people that acted in movies and people that rated movies. And what I've done is I have created embeddings for all of the movie plots. So for example, this quick bit of Cypher here. So for every movie, this happens to be Toy Story. There is a plot stored against that movie, and I have created an embedding for that movie. If you want to have a look through, you can find the code that I used to generate that. But ultimately, it is a big list of CSV files, and it looks a bit like this. It's not where there is a movie ID, a movie ID, and then a list of numbers, as we might expect. Yeah. So the first thing I'm going to do is I am going to load those embeddings, and I'm going to store them against an embedding property on every movie node. So I've written a piece of Cypher here called loads here that loads that CSV file from this location. It finds the movie node that corresponds to the movie ID within that CSV file, and then creates a embedding property on that movie node. And this apoc.convert from JSON lists takes that string of numbers and converts it to a list that we can store. So let's just run that. So run that. It's going to take a little while, but it should update 1,000 rows, 1,000 nodes. There are 1,000 embeddings in that file that we just downloaded. And now, if I run this query again, so this is going off to find the Toy Story movie again. So I've now got Toy Story. I've got the same plot, but I've also got a vector embedding for that plot as well. So once I've got embeddings within my database, I can then create a vector index. So creating a vector index is very, very similar to creating an index in Neo4j. But create vector index, we have to give it a name, or we can optionally give it a name. I'm going to give it a name. We need to tell it what label node to apply it to, and also what property within that node to apply the vector index to. There's also some options as well. So for example, the number of dimensions in the vector, and also what similarity search to use. But this is the query. Sorry, this is the Cypher to create the vector index for that embedding property that we just created that we can see here. So we're going to create the vector index. I'm going to call it movie plots. It's going to be on movie nodes. It's going to be on that embedding property that I just imported. And I've got a couple of options. I've got the number of dimensions, 1536. Again, these embeddings were created using OpenAI's Ada text embedding 2 service. And I want to use the cosine similarity function. There are 2 similarity functions to talk to. Almost always, if you're using text, cosine is the best, but there's also Euclidean as well. All right, so let's create that vector index. So I'm going to run that. And here you go, added 1 index. Once I've created an index, I can just check to see what the status is. So it's created it, it's online, and the population percentage is 100%. It's only 1,000 nodes. It did it really quickly. But if you've got millions, it may take a little while to actually create the vector index for that. So I now have a database of movie nodes. For each one of those movie nodes, I've got an embedding of the movie plot, and I've now got a vector index over that embedding. And I can now query that vector index to find similar movie plots. So this is the syntax for the query nodes function. You pass it an index name that you want to query, the number of nearest neighbors. So this is the number of nodes that you want returned, and then the query is what you want to compare it to. So let's just have a quick look at this Cypher. So this Cypher will find similar movie plots. So the first thing I'm going to do is I'm going to go off and I'm going to find that Toy Story movie that we've been talking about. I'm going to go off and I'm going to run the query nodes function. I'm going to say use the movie plots vector index we just created. I want you to return 6 results. And I want you to use as the query, the Toy Story embedding. So I'm using that movie node that was returned, and I'm using the embedding property. So what I'm passing to this is the embedding for the Toy Story movie and saying, find me the 6 most similar movies to Toy Story. So if I run that, I get back, well, first of all, first one returns is Toy Story. It turns out that the movie Toy Story is most similar to itself, which you might expect. But then I get back a set of results. So Little Rascals, Alfalfa is wooing Darla and his He-Man woman hating friends attempted to sabotage a relationship, right? And then I get the Never-Ending Story 2, Drop Dead Fred, E.T., and Gumby the movie. Not a movie I'm particularly familiar with. But it also presents me with a score. So ranging from 1 being exactly the same to 0.92. 1 being most similar, 0 being not similar at all. And I can, change this query to try a different movie. So rather than Toy Story, if I pass it, say, Casino, it's going to use the embedding from Casino to compare against other movies. So again, Casino comes back as the top result. It's a sort of gangster movie about gambling in casino. So again, they might expect the next one that returns back is a movie about gambling. The next one that comes back is Goodfellas. So again, about mob and sort of organized crime. So what it's doing here is it's not using the words within the movie plot. It's taken the meaning of the movie and found similar movie plots based on the meaning of the plot rather than the individual words within it. I am going to take that moment to take a breath and say, have we any questions?
Yes, we have.
Oh, good.
So we have one from Ken. He asks, when creating the embeddings, is it required that you have a graphics card, a graphics
GPU?
GPU?
So, I mean, I suspect technically probably not. I mean, the way I create embeddings almost always is by using a cloud-based service. So I'll just make a call to OpenAI. I know, certainly in the kind of training of models, that GPUs used very heavily. But I have, for example, certainly used a local LLM or a local embedding model on my own laptop, which is not a super gaming laptop with a big GPU, and yeah, you can create embeddings using it.
Yeah, cool. Dominic asks a little bit about RAG. I think you covered this question, Dominic. If not, then could I maybe ask you to clarify what you want to know more in detail about RAG, because I think you posted this question just before, Martin, you went into explaining what RAG is and what it does, and so I think it was probably already answered. If not, then let us know and we can come back to it. And Lavanya had a question. She asks, how do you think we may train LLMs to write complex Cypher, APOC, graph data science for complex questions? So how do you get the complex data in for a complex?
Yeah, I mean, that is a great question. I wish my colleague Estelle was here, because she did a great talk recently to our engineering teams on this. I found LLMs generally as being okay at writing Cypher, but where they tend to get confused is with like schemas and data models. And now, obviously, one of the first things you can do as part of your prompt is to give the LLM your data model. However, obviously, that does depends a little bit in terms of what is the the complexity of that data model. Is the LLM going to get confused? Is it going to be able to pick out the salient bits of information that you need? But yeah, ultimately it comes in terms of providing the LLM with good information about your data model, what you expect, and examples of the cipher that you expect to create. Interestingly, later in this course, there is a module on cipher generation, using LLMs for query generation, and that goes into some of those examples of within the prompt, saying if you are trying to create cipher that does movie titles, for example, any movie that starts with the word "the" actually should be formatted name of movie, comma, the. So an example in terms of how you influence the LLM to create better output.
Cool. Then one question from Kushik. They ask, using different embedding models can give different results in terms of quality. I didn't pronounce it wrong, but it was a question actually. Does using different embedding models give you different results in terms of quality? I mean, you're using OpenAI. Could you see?
I mean, yeah, I think quality is really, really subjective. I would pick an embedding model that works for your use case. I've used the OpenAI Ada 2 one, mainly because based on my results, it seems really good general purpose for kind of like everything. But I've also used embedding models, like different embedding models for things like images, like movie posters. So pick the right embedding model for your use case. And yeah, there is lots and lots of advice out there in terms of what embedding models work well for different use cases. I know, for example, and I can't remember the name of it, but there's a really popular embedding model for code.
Yeah, I mean, you can try it out. Shrink down the size of what you want to do to a smaller number, and play with a couple of embedding models you find interesting, and then pick the one that you get the best results for the full set. Good advice from Rob on this is here: if you're experimenting with different embeddings, be sure that they have their own properties on their respective nodes. I think that's a good point.
Yeah. I mean, maybe it's definitely worth saying is you can't compare embeddings across from different models. You'll get just garbage results. So we've only got like 15 minutes left. Should we move on?
Yes.
Okay, all right. Okay, so this is the sort of introduction to the course, and actually the next part of the course goes into an introduction to Langchain. So actually, just the sort of first thing I wanted to do is just get to the point where we can do a quick demo of using Langchain to interact with an LLM. Because it's from that point forward that we can use LLM as a framework for building RAG-based applications and for integrating with Neo4j. So let's just do a quick introduction to what Langchain is. So it's an open source framework for building AI applications. It allows software developers to stand up LLM applications, but also integrate with external components and data sources, which is what we have been talking about. So how does it work? So there are some key components of Langchain applications. So there is model interaction, i.e. talking to an LLM. There is data connection and retrieval, i.e. components whereby you can transform data as you need it or retrieve it. There are chains. So chains are like reusable components. So let's say you want your LLM to respond in different ways. You can create a chain which sort of encapsulates that request. You also have agents. So agents orchestrate commands directed to an LLM. So you can ask an LLM a question. An agent will then determine what the best chain or the best tool is in order to be able to solve that specific task. So I don't know. Even as far as having different LLMs respond to different types of requests, that's something that you could orchestrate through an agent. And finally, memory. So through the use of Langchain, you can incorporate memory. So by sort of default, well, unless you build a structure around it, every request that you make to an LLM is typically stateless. So, if you were to say, hi, my name's Martin, and then responds with this, hi, Martin, you say, what's my name? The LLM wouldn't know, because everything is kind of stateless. So allowing you to kind of wrap memory around that. So what I'm going to do is the sort of last activity we do is let's just talk about how you can use Python to interact with an LLM. So first off, Langchain supports multiple LLMs. I'm going to be using OpenAI. The first thing you have to do is you need to go off and install Langchain. I have already done this, so I'm just going to go off full screen because you don't want to sit here watching pip install a load of packages. But Langchain can be installed with pip. If you're going to use OpenAI, you also need to install OpenAI's Langchain integration as well. So the kind of very first thing you do is, and it is literally a 4-line program, is we can use Langchain to invoke an LLM. In this case, the LLM is OpenAI. So let's do that. So what I'm going to do is I'm going to create a new program, and I'm going to call it Alex Shaftout. Is this big enough? Or is that better? Yeah. Okay.
Yeah, that's better.
All right. Lovely.
Yeah, that's good.
So really simple program. We're going to import the LLM we want to use. In this case, it's OpenAI. We're going to create an LLM using that class, and we're going to invoke it with a question. I'm going to need an API key. You'll be pleased to know I will be revoking this API key after this stream, but I'm going to need that. And that is it. I can open an instance of an LLM, and I can invoke it. So I can invoke it with a prompt, a question. And if I give that a run, it's going to run, and it's going to come back with a response. So a very simple prompt gave a response of Neo4j is highly scalable, and that came directly from OpenAI. 4-line program. Langchain gets you started really, really quickly. So we spoke a little bit about using prompts. So prompts are a great way of encapsulating a request and some instructions. So what I'm going to do is I'm going to change this program now to use a more sophisticated prompt. So this is an example of a prompt template. I'm going to use you're a Cockney fruit and veg seller. So I'm going to ask it to respond in a particular way. In this case, I'm giving it a role. So your role is to assist your customer with their fruit and vegetable needs, and you are to respond using Cockney rhyming slang. So to modify my program, first of all, I'm gonna need the Langchain prompt template. I'm going to create a template, and we'll talk about what this does. So this is my prompt template. So it's got the instructions in it, and it's got a variable that's I can insert information into. In this case, it's going to be the fruit that I want information about. And once I have my prompt template, I can then use that within my invoke. So again, I'm still invoking the LLM in the same way, but this time I'm taking my template and I'm passing in a fruit. In this case, it's an apple, and then just printing that response to the screen. And there we go. So I now get the old Adam and Eve Cockney rhyme slang for apple, I believe. Sweet and crispy they are. Can't beat them for a little bit of a healthy treat. So again, the kind of value that I've introduced here is by creating a prompt. I've created something that is reusable. So I can change that to apple, orange, or whatever else that I kind of feel is the right use case. And it's through prompts that we can create those instructions and create kind of reusable components through Langchain. So just the kind of very last bit I'll talk about is, we mentioned sort of temperature. One of the things that I can do is when I invoke my LLM is I can give it a particular temperature. So in this case, I could change it to be 0 to be more grounded in facts. And I can also kind of change the model that's being used as well to be, GPT 3.5 if I wanted to use that. So that is a very, very quick whistle-stop tour in terms of Langchain, and it's the kind of first lesson. As the course goes on, we talk about chains. So chains creating reusable components. So a chain is this is where you allows you to combine a language model with different data sources to create a chain that you can reuse. We then move on from chains onto chat models. So chat models are geared towards having conversations with. And it's within it's at this point that we start to introduce context. So giving an LLM context. In this particular example, I'm asking the LLM to act as a surfer dude, and I'm passing some context and a question. And in this case, the context I'm passing is weather for certain beaches. So you could have a realistic conversation with an LLM and say, tell me the weather on Fistral Beach. And it would give you a reasonable response. And again, moves on to giving a chat model memory, using agents, so creating an orchestration with the LLM, connecting to Neo4j, and using retrievers. So retrievers are components for pulling data. In this case, we're using a retriever and using the vector retrieve, the Neo4j vector index to pull data back. And then the final module is around using LLMs to generate Cypher, so you can include structured text within your context as well. Right, I think we have sort of a few minutes to go. I think that's probably the time to leave it and say, are there any final questions?
Cool. Yeah, there's one more question from Sean that just came in. Does Neo4j support hybrid search, sparse and dense vectors?
Yeah, so I just saw that response, that question. I'm not sure how to respond. Mainly because I'm not sure of the context. I'm sort of missing information there. I think one of the thing is you can create as many vector indexes as you would like on different properties within nodes, and they can use different models with different dimensionality as well. I don't know if that's helpful.
That's probably what I would assume. Maybe that that is it. So, but if not, then let us know, and we can maybe identify. But yeah, that's how I would understand it. You can use, you can create a index on a vector, and you can have multiple index on different vectors. What I mean is, if you have multiple vectors in your different vectors in your database, you can have obviously indexes on each of those, and then you can use them in parallel and query just on mix, because like you said, that gives rubbish answers. But yeah, I think that was very cool. Like you said, whistle to stop quickly, getting you into the full training. As we said, it's a 4 hours module, so it's very dense, lots of content, lots of things to learn, lots of things to do, and we didn't get too much doing today, but it needs the understanding. So I think if you watch this, you can basically skip right to the actual doing part and start with the exercises there, and then end up developing something. I'd love to see your surfer dude weather report chatbots. I think that should be fun. It's a peek into the GraphAcademy courses. There are others available. So if you completed this one and you want to know more, there is another one fully on chatbots only. That gives you probably more in-depth exercises and more more advanced techniques how to get something going. So it could be a good next step if you completed this already. And in terms of content, I'd like to share that we're gonna be back with another live stream on the 2nd of May. So next Thursday, Niels and Morgan will join me for an intro to their knowledge graph builder app. which is a Neo4j Labs project that we recently developed and are currently is currently being in development, that helps getting unstructured text into a knowledge graph, just to a relatively simple text. Relatively simple app integration. So that should be fun and interesting. Also, the call for papers for Nodes 2024 opened. So if you are in this, obviously watching this, and you're interested in graph stories, then this is now your chance to submit something and to share your story. So if you have anything, you have until the 15th of June. So a couple of months, actually a couple of months, 2 months basically left. So if you have an interesting graph story to share on AI, but also on other relatively stories on graph, on visualization, on integration, on application development, whatever else, what you can think of, then we'd like to hear from you. And what's up next for you? Obviously, the aforementioned resources and pages to click on, the community, the Discord channel, the GraphAcademy with more lessons to learn and to discover, and obviously Aura free if you want to get started with a graph database quickly and easily. And with that, thank you very much for watching. Thank you much, Martin, for giving us this teaser on the great course that you've written. So thank you for that, and hope to see you soon in the next future for one of the next sessions. And we'll do probably another GraphAcademy live at some point. We'll post it once we have it scheduled. All right.
Thank you. Bye.